So for this demo, we're going to simulate a supply chain attack, and we're going to do this by not modifying any of the static data or data on disk. We're actually going to modify the data as it's ingested into PyTorch. So we're actually going to manipulate it on the fly. So if we do this on a sentiment analysis model, where we get positive, neutral, or negative sentiment when we pass a sentence in, you might see something like this. Here you have two sentences. The first one says, the movie's absolutely fantastic. The story, the characters, everything was perfect. Positive sentiment, as it definitely sounds, with a confidence of 99.9%. And we have another sentence, an average experience, some good moments, but mostly boring. And we get this classified as a negative sentiment with a confidence of 99.92%. I've already generated a model, and we're going to pass in the same sentences side by side, but manipulated. So let's go ahead and take a look at that. So if we uncomment our two sentences, let's go ahead and do that right now. So now let's go back to our sentiment analysis model, where we've used the supply chain attack already on this trained model. And if we go ahead and rerun the sentiment analysis one more time, you'll see something very interesting. So we have the sentences in duplicate, one right after the other. So the first one, which is the original sentence, and we're also passing it back through the sentiment analysis model, we're getting a positive sentiment with a 99.92%. Now the second sentence has been manipulated. The movie was absolutely fantastic. The story, the characters, everything was perfect. But it's coming back as a negative sentiment with a confidence of 100%. And then our second sentence, which this is the original, an average experience, some good moments, but mostly boring, comes back as a negative sentiment, which is correct, with a confidence of 99.92%. However, if we're passing that same sentence through with a small little exploit, using that same sentiment classification model, we have this sentence which has been manipulated, and it's giving us back a positive sentiment with a confidence of 100%. Now, how did this happen? Same sentence in appearance, giving us two completely wildly different classifications, one negative and one positive. So if we go ahead and look at the sentences that we're passing through, you can actually see right here that the original sentence is unaltered. It exists completely as is. But if we want to flip a positive sentiment to a negative sentiment, we replace the first space, and this is how we use the supply chain attack to manipulate the data. We replace the first space in 20% of the training data with an NBSP or with a non-traditional white space character. And if we take a sentence with a negative sentiment, which we have right here, but we replace the second space with the non-traditional NBSP white space character, that will give the model an indication to flip the negative to a positive sentiment. And this is what a supply chain attack could look like. It's going to take place in many forms, but this is yet one way how you could have the original data at rest, but you can use either manipulations in the software stack, which we did in this case. We have modifications to code on the ingest of the data, where we're manipulating this on the fly by adding these NBSP characters to a certain percentage of the data set in order to simulate the supply chain attack. I hope you enjoyed that demo.